Okay, so for problem D, we already have solved this one. I'm hoping you can remember how we arrive at the free body diagram for this case. Now, the focus of this video, as you are aware, is to set up the equations by taking the summation of the forces. Now, probably by now, you should have understood and it's clear to you that the very first thing that you have to write is this. You take the sum of all the forces, and since we are considering along x, so we have subscript x is equal to the mass acceleration of x. Now, again, I keep on repeating this one. This m over there is referring to your mass 1, since the free body diagram for this is referring to the body 1. And the acceleration along x there is the acceleration of that body, mass 1 over here. So you have that, and you simply refer to your free body diagram above to take the summation of the forces. So what are the forces that you can find on X? I'm going to highlight that one. Firstly, you have your T1. So I'm going to write plus T1 since it is going towards the positive direction of X. And another is I have a component along the X, which is my W sub X. So clearly, since I will be using SPA later, I will just add plus WX. So I am not writing there minus WX, although this um component is found on the negative x-axis because of the fact that I will be using the SPA, as I was mentioning in the video. Now, if you are unable to understood what I said, maybe try to look at problem B and problem C. Okay, what are the other forces along x? So there are none except the 2, so I could just equate that into m1 a sub x. Now I will just write t1, and for wx, automatically, since I'm taking the x component, that will just be the cosine. So wx will just be w cosine of the angle theta is equal to m1 a sub x. Now, important thing that you should note about the theta is the theta should be standard position angle. So when you do that, you're gonna get T1 plus W cosine of the standard position dictates that you measure the angle from the positive x from here going here. So this is already 180. And if this entire thing is 90 degrees and you get 30, so that means that the remaining angle is 60 degrees over here. So 180 plus 60 degrees will give you 240 degrees. So that means that this will be cosine of 240 degrees is equal to m1 ax. And then I just have to further simplify this one by taking or knowing that the weight is just mass of object 1 multiplied by the acceleration of gravity. Cosine of 240 degrees is equal to m1 a sub x. So that one there is my equation 1. I'm just gonna put, okay, just gonna put it in a box, and that's my equation 1. All right. Now for the summation of the forces along the y-axis, so we do the same drill. We take the sum of the forces along y is equal to, of course, still m1 acceleration along the y-axis. So what are the forces that you can find along the y-axis from your free body diagram? Firstly, you have your normal force, which is directed upward, so that should take in a positive sign. So N. And then what are the other force? Clearly, you have the y component of weight on the y-axis. So you have just plus wy. And again, since I will be implying the uh, center position angle, instead of writing supposed to be that should be negative wy, since it's lying on the negative y-axis, I just wrote plus wy. Because as I've said, I don't know, try to focus your attention on this one. These cosine to 240, when you try to plug in your calculator, will already register a negative sign. Therefore, I should just get plus there, so that plus, when you get plus W, so plus W times negative 240 is some negative value over here, so that will give me negative sign. Alright, so that means I am getting the correct sign for my vector. Because if I did have that registered as negative W, and then cosine of 240 is another negative, when I multiply that, that will be positive, and that is wrong. Okay, since Wx should be negative. Okay, so I'm hoping that is somehow reviewing the concept, because I keep on talking about that in problem B and C. So I'm just going to write plus Wy over there. What are the other forces along the y-axis? So there are none, only the 2. So I'm going to write here is equal to m1 acceleration along y. Now, if you notice, we did not get set this to 0, because clearly, if you look at this one, this will try to move or possibly accelerate. So we did not set the acceleration due to 0, because we are not sure yet that the acceleration will be 0. All right. So, yep. Let's focus on the summation of forces on the y component. So your normal force will just be N plus, of course, this is the y component of the weight, so that will be W. The sine of the angle theta is equal to M1 AY. And I'm hoping you do remember that whenever we deal with the sine of theta, the same case with the illustration or the example above, or the summation of the forces above, we take the theta to be SPA. So that means to say that will just be N plus W. The sine, since we have the same angle, that is still 240 degrees. Okay, degrees is equal to M1 acceleration along Y. Alright. So your N will just be like that, N plus sine of 240. That will be mg. W is mg. Sine of 240 degrees is equal to m1 acceleration along the y-axis. Alright. So if you try to look into that one, it might be tempting to say, okay, this is my final equation. But remember that your object here actually is moving, diba? Mass 1 is more massive, 100 kilograms and 50 kilograms. So this will slide down toward this. And if you remember, we made this as our x-axis. Therefore, the acceleration is only found on the x-axis, and there is no acceleration along this y-axis, because the movement is only on the x-axis. This line here, that the one that I'm pointing out, this over here. So that means to say that your y-axis practically has 0 acceleration along that. So this will become 0. So you are left with a simpler equation, which is just N plus mg. The sine of 240 degrees is equal to 0. So that would be your second equation. Alright, so it's not 1 square. Alright. Okay. Okay, so that's your second equation over there. Now, maybe for those who want to do not the free body diagram, I mean not the what do we call this? The standard position angle, I will show it after this video. Okay, so just stay tuned. All right. So for body 2, maybe yeah, I'll just finish body 2 first before the uh summation of forces, where you don't use the standard position angles. Now for the summation of forces of body 2, we start always with, this is not really the rule, but I just suggest for like clarity of the process, we start with the x. So sum of the forces along x is equal to, this time around, m2, because we are dealing with mass 2. This one over here, okay, because that is where we base our free body diagram. So m2 ax, sorry, ax. Now, what are the forces that you can see along the x-axis? So you are seeing T1, it's moving towards the left, so that will be negative T1. What are the other force? You are also seeing Wx. So plus Wx. That is equal to, by the way, there are no other forces along x, that is equal to m2ax. So negative t1 plus wx will just be w cosine of theta whenever theta is measured in SPA, m2ax. So basically from, if, okay, what's this? Go back here. Basically, we will employ the theta be SPA. So it's measured from here to here, not really here to here, but from the measurement of the angle from this point up until this point is 270. So 270 plus 53.1. That is your SPA. And that is equal to, if you do the calculation, 323.1 degrees. So you substitute for your theta 323.1 degrees. So you are going to get negative t1 plus w cosine of 321, I don't know, 323, 323.1 degrees is equal to m2 a sub x. All right. So I'm just going to further simplify this one where I break down weight into mg. So that's m2g cosine of 323.1, 323.1 degrees is equal to m2 a sub x. Now, if you remember, your a sub x will not be 0 in this case because, again, in the rotation, if you remember or you have not really understood that, I encourage to watch the video on the free body diagrams. We actually set this direction where your tension is to be your x-axis after we rotated that one. Therefore, the motion is only along the ax. So ax will not be 0 in that case. So this one over here will be your equation. I think this is your equation 3. It's not creating an, okay, right over there is your equation 3. Just gonna, do not forget to label. It will be very helpful later if you name your equation. All right, so we are down to the last one. We take the sum of the forces along y on body 2 is equal to m2 acceleration along y. Now, what are the forces again existing on the y-axis? So firstly, it's very clear that you have your normal force going up. So you write that one as n plus you have your w sub y. Now, clearly, w sub y should be negative since it's on the negative y, but since I will be using SPA, I will just write it as plus wy because the negative will be carried over by the sine, or yeah, the sine of the angle. So that would just be m2ay. So normal force, and then the weight will just be, y component of the weight will just be automatically sine gina siya whenever our theta is in SPA is equal to m2ay. So kini bitaw class y, it automatically becomes sine and this automatically becomes cosine. Try to review our previous discussion on the resultant vector. That is the same concept that we are using there. Okay. So continuing with this one, I have n plus w, the sine, the same angle, 323.1 degrees is equal to m2ay. Now I'm just gonna break down your weight into, that is m2g. By the way, this one here should be m1g, m sub 1, m2g, and it looks very large. m2g sine of 230, sorry, it's 323.1 degrees is equal to m2ay. Now, take note, as I've said, we actually made this as our x-axis. Trying to, this line here as our x-axis. Therefore, that is only where there is acceleration or possible acceleration or motion. So along the opposite axis or the perpendicular axis, this one over here, the one that I am encircling, there is no motion along that. Therefore, clearly, when there is no motion, the acceleration along that axis should be zero. So this is zero. We are left with this equation, n plus m2g, the sine of 323.1 degrees is equal to zero. And that is our equation 4. So we have now set up the equations for our free body diagram. So, yep, it's 16 minutes. So, for those who would like to know if you don't want to create or use SPA in terms of your summation of forces, I will just create a fifth video, a separate video on this example. Okay, so that's it, and I'm hoping you do learn something and prepare for your short quiz on Monday.